All right, so in the second video, we're going to be doing operations, meaning addition, subtraction, multiplication, and sort of division. You'll see when we get to that one. So the first one, we're going to be multiplying. For the most part, you'll just see the word simplify, and then the sign in the middle will just tell you what you're doing. So that little dot represents multiplication. So one thing to note is that you cannot multiply or add two things together unless their indices are the same. So see how you've got a little 3 in both of those. That means they're both cube roots. That means we're allowed to multiply them. So what we're going to do is multiply these two pieces together. So we've got the 5. That's just going to kind of hang out front, and there's technically a 1 out front of the second one, so it's like 5 times 1, and then times the cube root of, and then we just multiply all the like terms together. So 100 times 10 gives us 1,000. A squared times a gives us a cubed, and so that's where we're at so far. And then whatever you have under the root, whether it's a square root, cube root, you simplify it up as much as you possibly can. So again, we still have that 5 out front. And then this one, I'm taking cube roots. Everything that I have under there actually turned out to be a perfect cube. 1,000 is 10 cubed. 10 times 10 times 10 gives us 1,000. So the cube root just ends up being 10. And then the cubed root of a cubed means, again, what multiplies by itself 3 times to give a cubed. That's a times a times a. So this would be a 10a. So finally, we actually go through and multiply that by 5. So we get 50a, and that would be our final answer for this example. So that's what multiplication looks like. Look, we've got addition and subtraction. First, we need to quickly define what it means to be a like radical expression. It's a like radical expression if both the index and the radicand are identical. Okay, so if both the index, meaning they're either both cube roots, both square roots, you know, something like that, and the radicand are identical. And the radicand, remember, is that weird word that just represents whatever's under the root. So it has to be, they both have to be like the square root of 5, or they both have to be the cube root of 8. You can't have a cube root of 8 and a square root of 8. Those aren't like terms, things like that. So to simplify these, you can't add them together the way that they look right now because none of them have like radical expressions. So we simplify them, and we simplify them as much as we can and hope that we might be able to make some like radical expressions. So square root of 45. That one, for instance, can be broken down. 45 is 9 times 5, and 9 is a perfect square. And we can do the same thing with 80. 80 is 16 times 5, and 16 is a perfect square. And then 20, we can break that down as 4 times 5, where 4 is a perfect square. So you'll notice that you have a 5 left over with all of these. So once everything is all simplified, they'll all be left with the 5 under the square root. Those will all be like radical terms. So we've got 3 times, and then when we simplify this, square root of 9 comes out as 3, and then we still have a 5 under the square root. And then minus, we just hold this sign right here. There was a 5 that was already there. Square root of 16 simplifies up to 4, and then there is still a 5 under the square root. Plus, and then this third term starts with a 4 times, square root of 4 is 2, and then again there is still a 5 under the square root. So we're just simplifying these as much as we can. So 3 times 3 is 9 root 5, minus 5 times 4 is 20 root 5, plus 4 times 2 is 8 root 5. And now you can almost treat the root 5 as like an x. Since they have the exact same radical part, we can just add these numbers in front. So 9 minus 20 is negative 11, plus 8 is negative 3. So this ends up being a negative 3 times the square root of 5. And again, that root 5 is treated almost like the variable. If you were adding x's together, you wouldn't change the x. So since we're adding and subtracting root 5s, we don't change the root 5. Okay, so that's what addition and subtraction looks like. This is multiplication as well, but it's different from the one we had on the previous page. This one, it's kind of like a foiling sort of situation because we have a binomial right here and a binomial right here. We're going to FOIL that all out. So first we multiply these two together. So we multiply the 2 times 3 and we get 6, and then the root 3 just kind of hangs on from this piece right here. And then next is outside, multiply these two terms together. So 2 times what's technically a negative 1, I have negative 2. Square root of, when I multiply square roots like this, root 3 times root 3 leaves me with root 9. And hopefully we recognize we can simplify that. We'll do that in just a moment. Inside right here, 3 times 3 is 9. And then the square root of 5 just kind of hangs on. And then finally last, 3 times negative 1 is negative 3. And then root 5 times root 3 is root 15. Okay, so we're going to see what we have that we can simplify here. Root 3, there's nothing we can do with it. Root 9, remember the square root of 9 is 3. So this equals 3. So I can write this as 6 root 3, and then minus 2 times 3 would be 6, plus 9 root 5, minus 3 root 15. Now if you look at all of these radical parts, none of them are the same, and actually none of them can be simplified the way they could up here. So this is all you can do with this answer. That is, unfortunately, I mean, it's a little messy, but that's as simplified as that one gets. Okay, next one, we're going to do what's kind of like division. So remember conjugates from imaginary numbers. You had a plus bi, a minus bi. Conjugates with square roots is very, very similar. So say you had a square root that looks something like this. So you could have numbers everywhere, which is why I have 4 variables written here. So you could have a number on the outside, number on the inside, same thing with the second term. So we have a root b plus c root d. If that's the original, then its conjugate would be a root b minus c root d. Remember with the complex numbers, a plus bi, a minus bi, the only thing that changed was the operation in the middle. Addition changed to subtraction and vice versa. So the way that we simplify, if you've got any sort of square root terms, because remember you're not allowed to have a radical in the denominator. So in order to get rid of that radical in the denominator, we multiply top and bottom by the conjugate of the denominator, which again should sound very familiar with what we did with complex numbers. So the denominator is root 3 plus 4, so we multiply top and bottom by root 3 minus 4. And then it's really similar from that point to the stuff that we were doing up above. Lots of foiling, lots of combining up like terms. So in the numerator we're going to FOIL out. We're going to have 6 times root 3, which we just write as 6 root 3. Outside 6 times negative 4, so minus 24. Inside negative root 3 times positive root 3. That actually ends up being just a negative 3. Because it would have been a negative root 9, which we know will be 3. And then negative root 3 times negative 4 is plus 4 root 3. And then all over in the denominator, we have root 3 times root 3, which like I said, just comes out to be 3. Starts out as root 9, and we can simplify. Outside is root 3 times negative 4, so negative 4 root 3. Inside right here, positive 4 root 3. And then last, positive 4 times negative 4 is negative 16. So you see what happens in the denominator is these two radical pieces will cancel, which is exactly why we use the conjugate. It makes those middle terms cancel, and then we won't have square roots anymore. So in the numerator, I have 6 root 3 plus 4 root 3, so that's a 10 root 3. And then negative 24, negative 3. And then in the denominator, I have 3 minus 16, so that is a lovely negative 13. And really all we could do with it from that point on is to maybe divide both of the pieces by the negative 13. You don't have to. You could leave it like this if you wanted, or like I said, divide each of those pieces by the negative 13, and it would look like that. Really, either way is totally fine.